Okay, so we're going to look at Venn diagrams for a few minutes. We're going to first look at two set Venn diagrams. And within that we will see set operations, which are intersection, union, and complement. And we will see counting. Okay, and in both of these that will involve some shading. And then we'll do the same thing with three set Venn diagrams. So first, a two set Venn diagram. We need this flag that represents the universal set. So it's the set where everything comes from. And then if we had two sets in here, they may overlap like this. Okay, so if we have two sets, let's call this one A and this one B, and this is a universal set. So an example using some numbers or letters. Let's say we have a universal set. Let's go up to H. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so suppose we have a set with 8 elements in it. And they could be names of people in a classroom or something else, any list of items. Okay, and then we have the set A, and suppose that A contains A, B, C, D, E. And then we have a second set B that contains D, E, F. Now, if you look at these sets, we'll go into a Venn diagram and show where these would be. So, the universal set would mean that somewhere in these regions, there are 4 different regions, 1, 2, 3, 4, these letters would appear. Now, in the circle A, so that's this circle, we would have all of these letters, A, B, C, D, E. So somewhere in here. And B would have D, E, F. So that would be in B, somewhere in here. Now you notice they overlap. So if you look at the two sets, you'll notice that they both have a D and an E. That's the overlap or the intersection. We would say A intersection B is D, E. That's where they have in common. So if we were going to write D and E, it would be in the intersection. And then A, what we already wrote in A were D and E, but we still need to write A, B, and C. So those would be over here. And the only thing left in B is F. So remember this whole circle because we already have D and E in there, so F. And then what's missing from the universal set? So we already wrote down A, B, C, D, E, and F. So we're missing G and H. They would be in the outside in this region. Okay, and that's a way to organize it. So you could quickly look and you could ask, what is in B but not in A? So in B and not in A. So that's what this would look like. We're in the B circle and not in A. So in this B circle but not A would be the element F. And if I said, for example, A union B, union you can think of like an add. So it's everyone in A, everyone in B, all together. So everyone that's in A is A, B, C, D, and E, and then everyone that's in B that we haven't already listed. Right? So we've got everyone that's in A and everyone that's in B. You don't list things twice in a set, so that would be A union B. Now, shading is just to show those regions separately. So we can make it complicated or not complicated. But basically, I like to label them underneath. So if I were to show A intersection B, you would shade in where A and B have in common. And that would be the Venn diagram for that. Let's suppose that I wanted to shade in A union B. So remember, like I said, this is like an add, a union. So we add all of A and all of B together. It's important to put the flag because it's showing that it's what's in these three regions but not in here. Because I could ask you something like this. Let's say we had A complement union B. Now, this one is not hard because the union is like add. So anytime you have a union in there, it's not very difficult. You color all of A complement, so that would be everything outside of A. Okay, so right there, that's A complement. What's not in A. Sometimes they'll write that as a little prime. And then union means in the same drawing, color in all of B. So we have part of B colored in, but we want to add this part to it. And that would be it. So this would be A complement, what's not in A and also in B. It's okay that part of A is colored in because it's sort of like a party. Everyone that's not in A on list A, so if we look up here, everyone that's not in A would be F, G, and H, so they all get invited, everyone not in A. And then everyone that's in the list B gets invited as well. So we're adding these three to those. And so if we look over here, the only ones missing would be A, B, and C. Because they're in A, but they're not in. Okay, so that's two set Venn diagrams. Now on your assignment, there's a tricky one, and it gives something that is contradictory to this. It asks you to draw a Venn diagram. So, and just off the top of my head, I don't remember it exactly, but it's saying that A intersection B is the empty set or nothing. Okay, I don't, either of these symbols work for that. So A intersection B would, so A and B would not overlap. So that would satisfy this. But if we said, for example, we wanted A intersection, so let's write that down here. A intersection B is empty. That means they have nothing in common, so that would be an example of that. But what if I then said that A union B is the universal set? So that means if I colored in all of A and all of B, that I get the whole universal set. Well, this one doesn't work for this. If I have A and B, if I color in all of A and all of B, that's not the universal set because I have this part out here. So that wouldn't work. Now what if I did this? Instead of drawing circles, I just broke it in half. So here, A intersection B, they have nothing in common. They're two separate pieces. But if I shade them all in, I would get the whole universal set. So this would be an example of how to draw A and B so that both of these work. So here I would say A union B is not the universal set because we don't have this outside piece. All right, so you can have little situations like this, but basically this is what you see most of the time. Okay, now what about a 3-circle Venn diagram? So the way I draw it is 2 side by side, just like we did in the 2-circle, and then add a third one here. So now instead of 4 sections, if we look, we have 1, 2, 3, 4, 5, 6, 7, 8 different pieces that could be colored. So it makes things a lot trickier. So let's do shading of it first, and then we'll do a little word problem. Okay, so for shading, let's suppose I want to draw A intersection B intersection C. Let's write a couple of these down. A intersection B union C. A complement intersection B union C. Let's put these in a bracket. A union B intersection, B complement intersection C. Okay, we'll do these. Now, anytime there's intersections, you are comparing. So, compare. So, for example, if I were to do A intersection B intersection C, we should be able to do this without thinking too hard. If we have A, B, and C, this is saying what do A, B, and C all have in common? All three of them have this section. So A, B, C. This is a universal set. So that's easy enough. Now if it doesn't have brackets, we're going to go from left to right. So what we would do first is A intersection B. So let's draw that. So I'll just label it under here, A intersection B. So that's what A and B both have in common. And then this one isn't too difficult because what I want to do with that now, I've got that answer, I want to now union it with C. So A intersection B, I want to union that with C. Now, A intersection B is here, and union is, remember, like add. So I have the intersection, and I'm adding all of C to that. So that's what it would look like. Okay, so that would be your final answer. Okay, so this one's a bit trickier. We might need more room to draw it. So what I would want to have is B union C separate and A complement separate, and then I'm going to put them together. So let's draw A complement and B union C. Two side by side and one underneath. So B union C. So A, B, C. B union C is all of B, and add to it all of C. So here's B union C. A complement is everything that's not in A. Okay, so there it is. Now we want to intersection or put those two pieces together. So when you are intersecting, taking the intersection of two different sets, we're comparing. That's like a compare. We want them both colored. So we're comparing those 8 pieces that I talked about earlier. There's 8 different sections here, and we're looking at the two and seeing where are they both colored. Well, the outside is colored here, but it's not colored there. But you see this part of C is colored in both. So we'll shade that in. What else is colored in both? This piece right here, and that part of B, the very center, no. because nothing in A is colored for this one and outside. So this would be it. A complement intersection B union C. Okay, so we have one left, and so look up here. We have A union, so we're going to add A to whatever this is. So we'll figure this out first. B complement intersection C. That's an intersection, so we're comparing these two to find it. And then we'll add to it all of A. So this was the answer. And sometimes you need to show some parts, and that would be how you would get some part marks to do that too. Okay, so what I wrote for D was A union B complement intersection C. So here's A, and I want to union that with something called B complement intersection C. And then I'll get my answer. Okay. A is easy. Color in all of A. Now this one you might need to think about. So B complement, let's draw it here. B complement is everything outside of B. So here's B, and we would want everything outside of B colored. Okay, so that would be B complement. And we want to intersection that with C. C is this circle. So to do the intersection, you're comparing, and you say, where are they both colored? Well, they're both colored in this section, right here, and right here, this part of B. Anywhere else? They're not colored here, so they wouldn't be. They're not colored on the outside, so the outside isn't colored. These two are colored in this diagram, but they're not colored here. So that would be B complement, so anything outside of B, but is in C. And now we want to union those together, which just means add them on top of each other. So this one and that one, all of A, all together. So this would be your final. Okay, so I'm going to give you one to try. You can pause the video and try it, and then start it up again, and I'll have the answer. So write this down. So you're going to go, I don't have brackets, so you're going to go left to right. Okay, so pause the video and then come back in a minute and see if you get the right answer. Okay, so what you should do is A complement. You could even do all three of these separate if you wanted to. B. And the third one is C. Okay, so let's shade these. C, B, and not in A. I sometimes tell people, like, if you put a coin here to cover or to draw your circles, if you like being a little neater than I do, then you could cover up that circle with your coin and just color in all around it. So there we go. Highlighters work well for this. Better than these markers. Okay, so what do we want to do with these? We're just moving left to right. So these first two together we want to do the intersection. So the intersection, remember, is to compare. So where are they both colored? So it has to be part of B. This part is colored in both. And right here. And none of A is colored here. The outside is not. I think that's it. So that would be. And then what do we want to do with C? We want to union it with C. And union means like add. So we would take these two parts and we would add to it. So that was this one. And we want to add to that all of C. So let's just label it. There. And that would be our answer. And sometimes you can get to the answer without doing so many steps, but if you're having a hard time, the steps are useful. Okay, so what I'm going to do in the next video is come back with a 3-set Venn diagram, but with numbers, just so you can see what type of question we would use this for.